coming up.
We usually state that the reason why we're here doing what it is that we're doing is 80% of safety. 20% is for ensuring that we have smooth operations. When it doesn't work, we have to shut down operations, and that could potentially cost billions. And the main difference between oil and gas and offshore wind is that when we have oil and gas, you usually have people out on the oil rig to maintain all the systems so that you can do regular maintenance, you can do everything ad hoc as it happens. In offshore wind, you don't have people out there to ensure that if we have a helicopter coming from the outside going in to search and rescue and things like that, then we need to make sure that we can also communicate with those. And we need to make sure that we have fallback systems or fallbacks to rely on. So you can say all the fallback systems that we have or functionalities that we have within TETRA is playing very well into the way that we operate, at least looking at it from a safety perspective. And the more wind farms we get to operate, the busier our operations gets. And unless we are to just man up all the time, then we need to think differently on how it is that we operate.
Welcome to Making Waves, the podcast where we explore technology, people, and the real-world challenges shaping the world of telecommunications, particularly critical communications. From PMR radio to next-gen broadband, we talk to industry experts and frontline users to uncover the pain points, innovations, and decisions that define performance under pressure. If it keeps trees connected where it matters most, we'll be talking about it here. I'm Stuart, and with my co-host Hauke.
Hello.
And Lona.
Hi.
This is Making Waves. So, what do we have today, Lona?
In this episode, we're diving into the world of renewable energy, where systems are remote, risks are real, and downtime can cost millions. We are joined by Michael Mikkelsen, Head of SCADA and Communication at Ørsted, to explore how robust communication systems are helping ensure safety and performance in some of the most challenging environments, both on sea and on land. Michael, welcome to the podcast. Could you just tell us a bit about yourself and your role at Ørsted?
So I've been in Ørsted for 10 years now, and before that I was a contractor into Ørsted as well, delivering some of the early stage communication systems on some of the first big offshore wind farms that we constructed. And then in 2015, I started as a radio engineer in Ørsted. And I guess in 2019, I became the head of radio communications, where after which the department have grown significantly, also because of the company growing significantly as well, of course, leaving the need for a bigger focus on radio communications. And then just now, I transitioned into the position of head of SCADA and Communications.
All right. Very interesting. Michael, what role does radio communications play in keeping its energy operations running safely and efficiently?
It's a slightly tricky question. So when everything functions, nothing, at least if you ask the users. So usually it's not important when it works. But as soon as it doesn't work, it has a critical role to play. So we usually state that the reason why we're here doing what it is that we're doing is 80% of safety. So to ensure that all the workers that we have out offshore is safe and that they can call for help. 20% is for ensuring that we have smooth operations. And luckily, people usually don't use it for safety purposes. And that is also the reason why it's never really noticed until it's there. But when it doesn't work, we have to shut down operations, and that could potentially cost billions in revenue. So it is fairly critical that it works, and it works reliably.
So it has two sides. It is a lifeline on one hand, an insurance for your workers, and on the other hand, it has direct impact also to your revenue then.
You can't say it has a direct impact, but it definitely has an indirect impact.
Yeah. What do you consider unique about those requirements that you have, the comms challenges you're having working in offshore and maybe also on onshore wind farm environments?
So before I came into Ørsted, I also used to work for oil and gas. And I wouldn't say that all offshore segments are the same, but you could say some of the things that are the same going between oil and gas and offshore wind farms is the rough environment that is out there. So you can say the salt water and the wind conditions and everything that is out there. If so, the equipment needs to be ruggedized to endure the environment that is out there. And that is critical to make sure that we have, I could say, a sound installation so that is also operational. And the main difference between oil and gas and offshore wind is that when we have oil and gas, you usually have people out on the oil rig to maintain all the systems so that you can do regular maintenance, you can do everything ad hoc as it happens. In offshore wind, you don't have people out there. So you have to do maintenance plans, you need to do preventive maintenance or see things are happening and then planning ahead. And then you have weather conditions that makes it impossible to go out there and actually fix it and so on and so forth. So when we do the designs, we need to think ahead, and we need to think a lot about redundancy in situations where in oil and gas, we'll probably say, well, we'll have the spare parts there locally, and then we'll change it if needed. Here, we need to think about it needs to be changed, and then we need to change it, the redundancy part of it instead. So it's a slightly different mindset. And then, of course, also making sure that, so these trips are not cheap either going out there. So we also need to make sure that it is reliable equipment that is installed out there.
Okay, so that means you're planning the preventive maintenance long ahead before it really happens. And you need to probably align this with your colleagues in different departments, different stakeholders in Ørsted?
Yeah, definitely. Organizational-wise, we are divided into roughly two segments. So we have the EPC part, so the construction part of things, and then we have the operational part of things. And then, of course, you could subdivide those two areas into other areas as well, but those are the main parts. And I'm in the construction part of the business, and our customer is the operational part of the business. So we need to make sure that what we are delivering is what they need, and that when we deliver this to them, that they get all the maintenance plans that they need, or at least that they get with the material so that they can create the maintenance plans that fits into their schedule as well.
Yeah, it sounds like a complex procedure really that you have to follow to accomplish the mission critical operation of the system there. So you think there's a direct link between the infrastructure performance of the communication system and the operational needs that you have from the wind farms?
Definitely. It's not, you would say, from our side, of course, it's to some extent complex, but it's also fairly straightforward because we're basically just looking at the specs, and then that is what we're providing into operations. To create the plans is what operations are doing. That is a lot more complex also because they need to fit it into all the schedules along the way, and they need to make sure that we don't have any unnecessary trips along the way, and God forbid that we have any unscheduled breakage along the way as well.
Yeah, right.
I just want to pick up on that, Michael. The resilience in the harsh environments is obviously key to the sector working. You're in the middle of a sea. You're not covered by other technologies like mobile phones. So things have to work, and you have to plan ahead. Bearing all of that in mind, are you particularly relying on specific technologies? Which technologies? I mean, there are many options for you. There's TETRA, there's DMR, there's satellite, there's LTE. Is it a mix, or do you tend to favor one over another?
It is a mix, and that again comes down to numerous factors. So one of the things is that we have, now that I state that we have operations as the main customer, but then of course we can subdivide that into other areas as well. And if we go into the details, then we have helicopter operators, and obviously they have their kind of communication. So going back into history, most helicopters comes with VHF AM, and now I know that Sapura has come with radios that are now approved to go into the helicopters, and we can do that. But then again, some also stick to tradition, and then they don't want to change the radios into the helicopters. And if we lease them in, then we can't really dictate exactly how it's going to be. So to ensure that if we have a helicopter coming from the outside going into search and rescue and things like that, then we need to make sure that we can also communicate with those. Same goes with maritime communications, where VHF FM is the main communication system, and we need to make sure that we can do emergency contacts on channel 16s and so on and so forth. But looking into the main systems, we have for the last, I guess since 2008, we have been relying on TETRA as being our primary means of communications. And that is based on that it is critical communications for us, and we need to make sure that we have fallback systems or fallbacks to rely on. So and you can say all the fallback systems that we have or functionalities that we have within TETRA is playing very well into the way that we operate, at least looking at it from a safety perspective. Then obviously nowadays we're also looking into data connectivity, because that is the way that the world is moving, and we are looking into MCPTT or MCX or whatever we want to call it, but we also want the reliability and we want the standardization. And you could say when DMR went into tier 3, we could have shifted into to DMR, then we would get the same functionalities as we do in TETRA, and then it potentially could be cheaper. But then again, that depends on what manufacturer do you have, and then you can't interchange between the different manufacturers, at least not with the same functionalities going across. Whereas in TETRA, you get more or less same functionalities, not on the infrastructure, of course, but on the user side of things, which is key when it comes to it, right? With that, saying that we want to have the flexibility that we are not locked to one specific manufacturer. So there could be a ton of reasons. It could be that they go bankrupt. It could be that they choose to go in another direction that doesn't fit into our portfolio. It could be all kinds of reasons why we don't want to move along with that specific manufacturer. It could be similar to some of the national networks that we've seen, where the fire department go in and say, we're not going to use that terminal because we don't like it. We want this one instead. We could also have users that would go in and say the same. And then we want to have that option to go in that direction as well. So we want that flexibility. And right now, if we look into MCX, if we choose for someone now, then we're married with that company. So the standard is not there yet. The stability is not there yet. We do not have a DMO kind of setup that, well, we do, but it's not really functional. But what we then do have is that we have the hybrid terminals that we could use, we could go into, but again, then we're married to one specific manufacturer, which we don't like. So we're looking into it, and we're definitely moving into that direction. But for now, we're probably still married with TETRA for the primary means of communications.
Okay. So what I'm hearing from what you're saying, it's right technology in the right place. And until there's a like-for-like swap out, there's no reason to change. From what I'm picking up from what you're saying, in your world, you need to have choices. You need to have different technologies for different reasons: broadband, critical voice, ground or sea to air communications. Just give us a little insight into your world then. Is it a requirement that you always have two different technologies? How does the fallback and fail-safes work in your world?
So legally, we are obligated to have at least minimum two means of communications. What that then means is up for interpretation. What we have chosen to say is that means two different kinds of technology. So usually we are relying on, it depends a bit on where we're at, but either on IP telephony, bearing in mind that TETRA is our main means of communications. So that would always be our primary. And with that is fully redundant. And on top of that, you can say we have the fallback option in case something happens on the infrastructure. And then we have the DMO mode. So of course, if people loses their terminal, then we have an issue. But then we have either IP telephony or Wi-Fi calling or similar. So, and in some cases, we also use satellite phones as secondary means of communications.
How does that work then in terms of latency? Is it something that works well? I imagine it's not just a case of bad weather. There's all sorts of atmospheric and, in the case of satellite, go and return path considerations and constraints. How does it work for you then?
It works in an emergency. It would never be our first choice to go into satellite communications. We have scenarios, like we have operational scenarios, and then again, bearing in mind that operationals is probably 20% of what it is that we're doing. Everything else is safety, right? But we do have some operational scenarios where latency is an absolute no-go. So we have scenarios like craning scenarios and hoisting scenarios where we say even the maximum of 300 milliseconds on TETRA is too much of a delay if you ask the users. So they usually use a full duplex call in these scenarios to make sure that they have a direct line to speak on without any delays. The usual up to 600 milliseconds delay that we have on the satellite links is okay in case of an emergency, and it also works in the early stages. So when we have blue water, we have absolutely nothing out there. Of course, we still need to be able to communicate. It also works with satellite communications, but it's more as a fallback than anything else.
Michael, you mentioned direct mode. What role plays direct mode in your communications? I mean, there's not many users out there, especially for public safety, using direct mode. So I found it very interesting that you said this is important to you.
It is in multiple scenarios, actually. Going back to the blue water scenario, on the simple and easy setups, we use direct mode as a means of communications into shore, and then we actually have a satellite link linking that in between. Now with Starlinks and or in general low orbit satellite systems, it has become a lot more functional than it used to be. But even with the other satellite systems, it also works to have a direct mode scenario where we then use that instead of having a full base station set up out there. So usually we could use fixed radios with a indirect mode to ensure communication in the early stages, instead of using a full base station. And the reason for that is usually because of power consumption. So in those stages, we can then settle with having solar panels or small wind turbines to drive the setup rather than having a diesel generator or something like that out there.
Okay, that makes sense, yeah. Okay, and that direct mode is quite powerful compared here to LTE proximity service, where you have a very, very limited range, and for direct mode, it gives you some sufficient coverage then, yeah.
It does. And the efficiency of the amplifiers on TETRA versus LTE is also significantly higher. So we lose a lot of power on LTE still, unfortunately.
I know you have been talking about it already, Michael, cost, efficiency, and total cost of ownership. But how do you balance the cost of maintaining a robust communications network with long-term operational needs?
I will try and answer it fairly simple, and probably alluding a bit to what I mentioned earlier as well. So the key thing is that when we design the systems, we need to make sure that it is a robust system that we are installing out there that does not require a ton of regular maintenance. So a lot of the operational cost that we have is traveling back and forth into the wind farms, and to optimize on that, we need to make sure that the systems are not maintenance free, but at least that if we can settle on regular maintenance and planned maintenance, then it's a lot better, so that we can make sure that we can bundle the work that we're doing out there. And this is not my department, but I know that the operational department is doing a huge job in making sure that these schedules are planned at least a year ahead to make sure that they have everything planned out on all the different wind farms going forward. And that is critical to make sure that it is balanced and that we do not have we'll always have unforeseen costs, obviously, with the environment that we're in, but at least so that we can limit it as much as possible.
So what does cost of ownership mean in your sector? Are there any hidden or recurring comms costs others might not sea?
Going back to what I mentioned earlier, that we have some of these legal requirements that plays a role in how we operate. And some of it is something that we never use, but it is a legal requirement that it is there. And some of this is, for instance, to have a line to the outside emergency services. We also have similar like telemedicine in Germany, where we need to make sure that we have a data link into the doctor services that is onshore and these kind of things that we need to make sure that is there. And that also means that we have some, in the old days it was PTSDN lines, and now it's ISDN lines instead. But it's there and we're maintaining them, and it is about to be an obsolete technology. That also just means that it's more and more expensive. But to make sure that we can live up to the legal requirements, we need to make sure that they're still there. At the same time, of course, we also need to make sure that the network is reliable as well. That also means that we usually have redundant sets of network connections, so everything is more or less redundant all the time, to make sure that if something fails, that we don't have to shut down everything, but that we can actually continue on operating and then go out and fix it and then make sure that we're still operational. So we more or less have two of everything.
Are you investing more in comms as your operations scale globally, or are you more consolidating the infrastructure?
That has changed, and I think this is actually something that I have been debating quite a lot recently. As the company has grown and as we construct more and more, obviously, luckily, we also get more and more wind farms to operate at the same time. And the more wind farms we get to operate, the busier our operations gets. And unless we are to just man up all the time, then we need to think differently on how it is that we operate. The easy way would, of course, be, and this is how we did previously, that we just constructed one wind farm and then we operated one wind farm, and that was fairly easy to kind of do. But now that we have grown as big as we are now, and with the amount of wind farms that we have operating right now, then we need to think differently to make sure that we are efficient in the way that we are operating. Also on communication, that we need to think how it is, what kind of systems is it that we install, what kind of synergies do we have from one wind farm to another, do we need to cluster it together. In the UK we have clusters of wind farms on the east coast, we have clusters of wind farms on the west coast. In Germany we have the same, we have a lot of wind farms very close to each other. It only makes sense that they are operated together instead of having multiple operational sites. And that, of course, also means that if we are operating them together, then the systems also needs to work together. And this is definitely a high focus that we have now. And we are looking a lot into how we can make this more efficient, not only on the systems that we are installing as we go, but also on the legacy sites that we have out there, to make sure that the operation becomes more efficient. So we reconstruct the wind farms for 3 years, 4 years, maybe something like that, but they operate them for 30. So obviously that is where we need to put the focus.
There is an awful lot which I think that is not appreciated when you're putting a wind farm together. And you've just mentioned that the lifetime is 25, 30 years, and then you probably have your own metrics for how operational that's supposed to be. You go down maybe once, maybe twice when you can do the maintenance, and there's all sorts of other considerations that you have to put in. Let me just take it in another direction now, because I want to pick up on some of the other things which we've touched on, but we can elaborate a little bit more. Obviously, Ørsted is a leader, and I want to talk a little bit about the strategy and sustainability in the comms strategy now. So as in your job, as somebody who works for Ørsted, how do you think about sustainability in your own communications infrastructure? As you're thinking, for instance, I'm not just talking about are you saving money because you produce your own electricity, but things like waste management and things like this.
Again, going back to the way that we operate. So some of the things that we are looking into now is to centralize our spare parts a bit more and have them administered from a centralized point rather than having individual warehouses. So to make sure that we actually utilize our spare parts the most. The same goes for equipment that we get in, that it's also refurbished and placed into the right places. afterwards as well. And you can say now I am a Dane, and in Denmark we have also the distinction between being from Jutland and being from Zealand, and I am from Jutland, and we are notoriously known as being cheap, and therefore I also hate to throw anything out if it is functional. And that also means that at least within the radio side of things, we have a massive lab, because every time that something is probably at end of life, we usually tend to take it into the lab, because then we could at least use it for something until it's not usable anymore. On the design side of things, we are actually thinking quite a lot about it. We have had special designed antennas made to make sure that instead of having them interchanged every 3 to 5 years, that they could endure a lifespan of 10 years instead. And that, of course, comes with the cost. But first of all, it has the materials are better for the environment. And at the same time, the overall lifetime cost would also be less at the same time. So CAPEX cost, definitely more expensive. OPEX cost, a whole nother story. But also going from glass fiber into a more enduring steel structure that can be reused again. So the only thing that we need to replace is the dipoles afterwards, in case they break. On the power side of things, it's always a balance, especially now with data coming in. One of my hobby horses is definitely on the LTE 5G side. I really don't understand why they can't make the amplifiers more efficient than they are. I really hate to see all the power that we're wasting in those amplifiers. But hopefully it will come at the time that we actually need to use it. But on the sites where it is possible, we try to use. And now, of course, speaking to them, it's a bit embarrassing, but I can't remember the function on what is it called. But the active standby, where you reuse the frequencies as well, where you just have your standby base station.
Yeah, keying down. Yeah, it's about keying the unneeded receiver. Yeah.
Yes, exactly. So we try to implement these solutions as well. But the key thing is as well that we have a robust and safe system. When we design it, our main focus is on not traveling too much to do maintenance, because that is where we will have the main emission. When it comes down to it. So we would rather pay a bit more there than later on.
So bearing these things in mind, we're on this journey of different technologies and different ways of doing things, different ways of doing maintenance. Some will include humans, some will include other technologies. Where do you see your role evolving within Ørsted in terms of new technologies and maybe even new markets?
I would love to say that we could actually influence the market, but bearing in mind that, and I think we can to some extent. I think we still have a voice in there. But I also remember the early days, and this is like very early days when I started doing critical communications. And there was one of the oil majors that came back saying, we want to have a certain terminal that could have like a full keypad. And the market said, you're not getting it. There was just like, there's no market for it. And eventually someone came out and say, okay, we'll do it. And they bought a lot of terminals within a short period of time. And that kind of drove the market saying, well, there is actually something there. And I'm hoping that we can kind of get into the same situation where that people are seeing that there is a market here and that we can actually define it, because we might not even say, the segment that we are in might not be the only segment, but for the green energy transmission to kind of, or transition to kind of keep on evolving, we need to make sure that we have the right solutions for us out there as well. And our solutions are just not the same that we have for oil and gas and or onshore. There is significant differences in the solutions that we have. And just see our every time that we do an installation inside of a turbine, well, that is a Faraday cage. We need to make sure that we have the signals going in there. That means that we need to have a repeater system in there. And when we go out to a repeater manufacturer, it's just like, yeah, you can get one, and then they're used to kind of setting up maybe 2 or 3 inside of a tunnel, and they're covered. We just need 100 every time. It's a different cost, and if they want the same price, it's not affordable for us. It's not a feasible solution for us. And these are the things where we say, okay, but it's not a small system we're installing, it's big systems that we install. There's a magnitude to it, what we're doing. And that is where I hope that the market will actually open their eyes and saying, when we say that we want something, we're not coming and asking for one or two, we're asking for 100, maybe even 1,000 over a short period of time. And when we go to critical communications world and so on and so forth, it's the blue lights that gets all the attention. Of course it is, because that is where the market is. But it would be really nice if they also realize that we are not a small customer. Yes, we are in the grand picture of things, but we still have a magnitude, because yes, it's just one wind farm, but it's a big thing once you kind of install the whole shebang going across. So I'm hoping that we can affect the market, but I'm also aware of that we are a very, very, very tiny bit in there, but that we still can have an effect somehow.
I think you're right. You are a significant player, and public safety is obviously indeed the lion's share of the market, but that's to say that business and industry, utilities and other users are not a very significant part of the market, and growing as well. So you never know, but there may be a tipping balance and you may get what you want.
Hopefully.
All right, Michael, let's move on with a slightly different topic. Let's talk a little bit of leadership, future direction, and what is the biggest lessons that you have learned in your role as head of communications for such a large decentralized energy network?
I guess sounds a bit cliche, but expect the unexpected. It's an ever evolving world. So obviously we have a pretty good foundation, and that is sound, but the world is moving way faster than we can keep up with. So our solutions are based 80% on safety and 20% of operations, but we are dictated by those 20%. And this is what we're hearing, this is what we're seeing, this is everything. And it's very, very difficult to make the users understand that it is the 80% that dictates the solution and not the 20%. Yeah. And that usually means that we design something and that is not how it's used. And that is something that you need to be aware of and that you need to follow up on and keep on following up on. And you need to educate your people continuously to make sure that they understand the importance of the equipment.
It's a bit like with vaccine, right? The better it works, the less people believe it's important.
Exactly.
Is there any insights that you would share with other industrial or utility leaders investing in critical communications? Any advice you would give other leaders if they're looking for communication solutions, what to look for, what to focus on, what are the most crucial things? You mentioned safety already. Safety is a big thing for you, reliability, things like that.
I think one of the things that you can extrapolate from this is you've already mentioned the close proximity to requirements to oil and gas. You're in a rough environment. So I'm thinking there's probably some advice in terms of best practices that you could follow. Maybe that's a direction you could give us some insights on.
Yeah, there are, but you can say, just to maybe to answer Hauge's question first, then that would be to think ahead. Don't think here and now, think about the future. So, and especially now being in oil or being in the offshore side of things, retrofitting something is extremely expensive. So if you need to retrofit on your legacy parks because you keep on changing all the time, because you try to keep up with the development or the evolvement of the technologies, then it's going to cost you a lot more than to have a strategy around how it is that you communicate. So we've been sticking to more or less the same foundation for the past 17 years or something like that, I guess. And that's definitely benefiting us. Of course, we're still retrofitting a lot, and we're also maintaining a lot. But were we to kind of retrofit everything on all the wind farms, then that would be a very, very costly affair. So think ahead and maybe stick to what is important. Listen to the 80%.
I think it's a very important what you said. Yeah, thinking ahead and also having a strategy in place, right? Think about what could potentially happen and in what direction it would move. Talking about that, any changes or innovations that you would like to see in the coming years?
I would love to see MCX go into an actual standard, not just on paper, but also in hardware, and that we also have a direct mode in there as an actual functionality. And if it's, for me, it's fair enough. If it comes in as a hybrid, obviously that creates some issues in frequency allocations and stuff like that. But fair enough. That's probably something that we always have, frequency allocation issues. But that would be a massive resource saver, I think would be the right term. So right now we are installing 2 systems where one could actually cover both, if only we had the right standard and that we were sure that it was safe. And on top of that, that the governments would release the 750 band for us, or the 450 band for that matter, for that purpose as well. Because if we are sticking to the free band that we have right now with the 3.5 gigahertz, again, going into how we were to install our systems, to get a functional system, we would have to install a base station on every single turbine that we have out there. And it's just not feasible to do so, not seen from a resource perspective in any way. So if only the government would actually go back and say, governments would go back and actually look into the frequency allocations and saying, okay, there is actually a private market out here that has a need as well. And what that need is, then that would be really, really brilliant. And if we then could have, I know that the standard is there, but we've been saying that for years now, and it's just not practical there yet. Yeah. Because if we could do that, then we could unfortunately, then that would mean that the area of TETRA is probably going down. But on the other hand, that also means that we are now evolving into a new technology and a new way of operating, but still with the same focus as we always had.
Yeah. Have you done some investigations when we say we would move down to 700 megahertz or even 450? What impact it would have in terms of how many sites you would need instead of one base station per wind turbine? How many would you end up? Do you know that?
So it depends on the wind farms, but let me give you just a quick example. So on Hornsea 2, that is currently one of the biggest wind farms in the world, we have 3 base stations to cover the whole thing. If we were to cover it on a 3.5 gigahertz, then we would probably have 100. It's a significant difference.
It is. And I think a lot of people don't appreciate, if stepping from one technology to the other, just what the step change is in terms of the number of installations you're going to now need.
Yeah, and you could say from my perspective, it sounds a bit crude, but we could do it. We could install it, but we have 30 years of operations and maintenance that we also need to think about, and that is not feasible at all. So we can see how much maintenance we have only on, and we changed from having over-the-air repeaters where we picked up the signal from the outside, so we had installations on the outside, to having fiber optical repeaters. So now, at least in a quote-unquote protected environment, it's not that protected, but it's better than being outside. We still have a lot of maintenance on these repeaters going on, and if we were to have these base station installations as well, it would be a huge cost, both cost-wise, but also on the environment as well. So it's not a feasible solution as it is, unfortunately.
I think that you've made some incredibly valid points. Lots of insights there that the listeners probably hearing for the first time. I'm conscious of time, so I'm going to start to wrap up. But let me just summarize. We talked about the environmental challenges. We've talked about the technology, the sustainability. Look through the lens of sustainability and how that affects your world. We've looked at technology changes as well, and the considerations that you're fighting with now, and what the world is going to look like in 5 and 10 years' time. So I want to thank you very much, Michael, for your time. And I just want to ask you one last question, if I may, before we sign off on this one. There may be people listening to this and they say, look, this is actually a really interesting area. And we heard a little bit about your background. Obviously, you started off, I think you didn't necessarily mention it, but I know through your bio that you started off in the Danish Navy. You worked your craft, became the engineer, and you've got to your position today with Ørsted. If people are inspired and wish to get into this area and follow the path, the technical path that you had, what advice would you give them to any of our listeners listening?
I actually don't know. I was just about to say I would give them the same advice as I do to my children. Do what it is that interests you and follow that path. That is kind of what led me to where I'm at today. Had you asked me when I started out, I would have never imagined that this would be where I ended up. I guess the key advice would be curious.
And is it an area that you see a lot of growth for engineers in particular?
I actually think yes. I think there's a massive need. I think this is one of the areas that it takes a long time before AI is going to take over this.
Definitely. All right. Well, that's a good answer. I think we'll sign off on this one. I just want to say thank you again, Michael. It's been very interesting. I want to thank you very much to Lona and to Howard. I would encourage you to check us out on all of our platforms that we're available on. That's all the major podcast platforms and YouTube. This was Making Waves. So from everyone here, goodbye.
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 Bye.
And thank you, Michael.
There we go. And it's goodbye from me. That was Making Waves. Thank you very much. Bye-bye.